So I'm Gail Schaefer. I'll be talking about open access time at the CHARA. And before I start, I just wanted to say a big thank you to Stefan and all the local organizing committee for organizing the Sharp Size conference. So it's been, with the pandemic, it's been a long 2-year wait, but it's really good to be here in Exeter, both in person and remotely. So during this talk, I'll be talking about the open access program at CHARA. And so since some of you in the audience are not yet users of CHARA, I figured I'd start with a quick 2-minute overview of the array. So CHARA is located at Mount Wilson Observatory in Southern California. In this aerial view here, you can see the 100-inch dome in the center of the photo. And if we zoom into the this cartoon version, you can see the outline of the CHARA array. So we have 6 1-meter telescopes arranged in a Y-shaped configuration with 2 telescopes along each arm. We have baselines that range from 34 meters out to 331 meters, and beam combiners that operate in both the visible and the near-infrared wavelengths. So on the longest baselines, this gives a spatial resolution of 0.2 milliarcseconds in the visible wavelengths and about 0.5 milliarcseconds in the near-infrared H-band. And the light is transported from the telescopes into the beam combiner lab through vacuum pipes. And we have a number of different beam combiners available. And so these are basically organized by color. The blue ones are the currently operational beam combiners. You'll hear a bit more about each one of these later on in the technical talks later on in the conference. So MERC-X and MYSTIC are our main imaging combiners that combine light from all 6 telescopes at once in both the H and K bands. We have our classic and Klein combiners. Those are the 2 and 3 telescope version, near infrared. And for a long time, those were our most sensitive combiners, although they're being rivaled by the recent upgrades to both MERC-X and MYSTIC. And our visible light combiner that we use right now is PAVO, the 2 telescope combiner. And then in purple are our upcoming combiners, both SPICA, which is a 6-beam visible light combiner that's currently installed at the array and is being commissioned this semester. So they actually are on Sky doing injection tests and hopefully finding first fringes this week. So maybe later in the conference, we'll hear an update from that. We're also, Cimarron is now going to be a new instrument, 3 telescopes working in the near infrared that is optimized for increased sensitivity. And so Cyprian Lansman has a poster on Cimarron out there, so check that out. And then in red are our past combiners, both Vega and Fluor. Vega was decommissioned to make room for SPICA. And so we offer community access time at the CHARA array. We began a trial program back in 2010. And in 2017, we received full funding through the National Science Foundation through their mid-scale innovations program. So we currently offer 40 nights per year to the community for open access time. And this is available both to US-based astronomers and to astronomers worldwide. The time is offered through NOAR Lab with a call for proposals twice per year. And these proposals are typically due, the deadlines are usually at the end of September for the spring semester and at the end of March for the fall. And so these are just some statistics on the open access time. And so in each of these graphs, the vertical dotted line shows the transition between this trial program of a limited number of nights to the full scale NSF funded program. And so in the histogram, the blue bars are basically the number of nights requested, and the red bars are the number of nights awarded that are available for the open access program. And so we have an average subscription rate of about, on average, a little over 2. And over 350 astronomers have participated in the open access program. This includes both principal investigators and the co-Is. And so I thought I'd spend a few minutes to review some of the recent science results that are coming out from the open access program. So this was a paper published last year by Tyler Ellis at Louisiana State University, who looked at measuring the angular diameter of an exoplanet host star And so this was work that was done in the visible using Vega and Pavo beam combiners, and also some low spatial frequency data obtained with the classic beam combiner in the near infrared. And so the star has a diameter of about 0.3 milliarcseconds. And so combining the angular diameter with the Gaia distance gives you the stellar radius. And you can also get the, combining the angular diameter with the effective temperature, you get the angular diameter with the spectral energy distribution, you get the effective temperature. So this gives you a way to get the mass and the age of the star from comparing the physical properties with the evolutionary tracks. And then combining that with the test light curve, you get the properties of the exoplanet. This is work done by Noel Richardson and Laura Lee at Emory-Riddle, and they resolved the orbit of a nitrogen-rich Wolf-Riot star. And so the visual orbit was measured with the 6-beam combiner MERC-X, and it has a semi-major axis of only 0.78 milliarcseconds with really nice precision on the measurements. And combining this with the spectroscopic radial velocities, you can get the masses of both the Wolf-Riot star and the O star in the system. And this is work that has recently been published by Leslie Morales and Eric Sandquist at San Diego State University. And so this is a visual orbit of a binary in the Precipice Cluster. And so basically this was a program that was started early on using the CLIMB-3 telescope combiner. These are the measurements in red over there. And when MERC-X came online with the upgraded camera and input optics, the measurements in blue are the MERC-X observations. And so again, combining the visual orbit with spectroscopic radial velocity, you get the masses of the two components. And combining the masses with evolutionary tracks, you get a revised age of the Precipice cluster. And then another program that was an open access program this past year was a Target of Opportunity program by Elias Hyde to observe bright nova when they explode. And so this was Nova Her that was discovered in June of 2021, and it was observed on 2 nights with the MERC-X combiner. And you can see changing the morphology, where you can see this expanding outward ring of material going away from the center of the explosion. And there's many other results based on, in part on open access time that are both being talks later in the week and also on posters. So check out also these talks and presentations, both on a lot of binaries, multiplicity surveys, and resulting diameters of stars and imaging program too. And I just thought I'd take a minute here that CHARA is hiring a new visitor support scientist. The job duties of the support scientist is basically to help with the visitor programs going from observing planning, helping to collect observations, and assistance with data reduction also. And also there's a strong component for outreach to the community to try to increase the number of people who apply to use CHARA time. And the application deadline is at the end of the month, so come talk to me if you're interested. And the next call for proposals for CHARA time will be at the end of September. This will be for the 23A semester from March through July. And visit our website if you want more details, or come talk to me in person or online. And thank you.
Finishing exactly on time. Do we have any questions in the hall, first of all? Yes, Christian, so you can wait until you get the mic.
Oh, yeah, I think there.
Can you repeat the question?
Oh, yeah, the question is what will be the limiting magnitudes for the Spica instrument? I think probably around 8th magnitude, I think is what their goal is around. And it will depend on it. There's there's like a low, a medium, and a high spectral resolution mode. So yeah, the brighter targets will be for the high resolution.
No, so we're just checking to see if there are any more questions online. Any more in the room here? If not, then I think that those of you who are here and also online, please do contact Gail to find out more. She's put up the website for the applying for time and also the job ad, but take advantage of being around and available for to investigate those opportunities. If not, then shall we thank Gail again?